Hello all technical people. Today in this video we are going to have a look at the repairing process of this 5 HP induction motor. This is a hoist motor that has a brake assembly. For identifying the health of a motor, you can perform a number of tests on the motor. The first and the basic one can be a Megger test, in which you connect one of the points of the Megger onto the body of the motor and another one onto the stator windings. If the continuity is coming, then the motor is completely earth, as in this case the motor is showing dead earth. This clearly indicates that there is an insulation failure. Another test that you can perform on an induction motor is a resistance test that can be tested by a multimeter. In this particular case, as we can see, the motor is showing an unbalanced resistance and one of the phases is showing an open circuit. This clearly indicates that this motor is short and is having an open circuit. Now the next process after having done the insulation balance test is to dismantle the motor and physically identify the cause of failure. All the nuts and bolts have been removed and now we can remove the rotor from the stator. This is a squirrel cage induction rotor for this induction motor. As you can see, the motor is showing an insulation failure in the overhang position. Now if this motor has to be repaired, then you need to remove all the stator windings and then cleaning it properly and then providing a fresh insulation depending on the class of an induction motor. This motor is an F class induction motor and hence we need to provide an F class insulating paper. After inserting all the coils in the stator winding, you need to tie the overhang position of the coils so that they becomes rigid and there is a less chance of a failure. You can now see here a paper being inserted between two coils. This is known as a separator and it is a must for separating the two windings adjacent to each other. Now this particular motor is having a set winding with the coil pitch as 8, 10 and 12. For obtaining a 1440 RPM, we need to make connections in a top bottom pattern with 6 leads termination or 3 lead termination ending in a delta. For this, you can start by marking out the jumpers. For marking out the jumpers, you need to hold on to the top end of the first coil and then count the fourth position from the first coil and hold on to the bottom end of the fourth coil. Mark these both together where they will meet and then start to scrape off the material from there so that we can twist it and then solder it further. As you can see, a sleeve is being inserted onto the end connections of the windings, as they are going to run over the overhang of every coil. Now you will be able to see here that every set has been connected from first to fourth in a top bottom fashion. After having connected the jumpers, now you will be left with 6 terminations, 3 ending in top position, 3 in bottom position. These can be terminated outside directly in a 6 lead fashion and then made to a star or a delta depending on the design of the motor. After pressing the papers downward in the slot, we need to test the motor. Now the first test we can do is a Megger test. Again, for the Megger test, you can start by fixing one point of the Megger onto the body, that is earth, and you can start by touching the end terminations one by one and see that there is no continuity present. This means that our insulation is healthy. Now you can varnish your motor and then heat it and properly dry the windings so that it becomes rigid and properly insulated. After assembling the motor, you can start by testing the motor by doing a Megger test and again the resistance winding test. In this case, we can measure the resistance as 3.8 ohms in each of the windings. This means that our windings are properly balanced and our insulation is also proper. Now the final test is running the induction motor. We can do this by giving a 3-phase supply to the motor and then measuring the current in the windings by a clamp meter. The current in this position is known as a no load current, and the load current will vary, and that will be much higher than the no load current. Thanks for watching. Do like